In the up to here, yesterday we have covered the HANA Studio administration, how to check the logs, trace enabling, memory issues, configuration of the parameter changes. So all those things we have checked, right? Today, let's discuss about the some other internal topics here. Some other internal topics here that is called the HANA delta merge, HANA delta merge operations. So this is one of the internal topic, which means here we don't require any manual intervention here. System itself will perform the automatically this delta merge operations and everything here. So how the system will perform here? How the system will perform this delta merge operations and everything here. So normally, if I take the any diagram here, suppose if you take here, so this is the our HANA host here, right? So this is the RAM slot. This is the RAM slot means in memory. This is the in memory slot here. So these are the file systems. Maybe let's take like a different way. These are the OS level storage. OS level storage called the slash HANA data and slash HANA log folder here. Slash HANA data and slash HANA log folder here. We have the two folders are available here. This is the RAM slot here. So normally, this is the RAM, okay, in memory concept here. So this is the storage concept here. Storage concept here. Storage concept here. So what will happen here? Normally, the RAM memory. So normally, RAM memory is divided into the two types here. RAM memory is divided into the two types here. One is the delta storage and the second one is the main storage here. Delta storage and main storage here. So basically the RAM memory will be stored, will divided into the two types here. One is the DS and MS here, right? So suppose if any data is coming to the outside to the HANA database means this is the HANA, okay? Enter this box is HANA here. Enter this box is the SAP HANA database here. Enter this box is SAP HANA database here, right? So here we have the host on inside of the host we have the SAP systems are running fine here. So normally what will happen if any data is coming means first it will store the data in the delta storage here. Means all the queries, statements, load, execution. So everything will happen, will execute the statements here. Why? Because the delta storage is optimized for the read, write, and compression mechanism here. Read, write, and compression mechanism here. So whenever if any data you are writing to the means any transactions are executing, any transactions are committing. So all those things will happen in the delta storage. All those things will happen in the delta storage here. Delta storage here. So in the delta storage, once the transaction is committed, so why? Because all the queries will be executed here itself only. So, but if the transaction is committed here, the committed data will go to the main storage. The committed data will go to the main storage here. So if the transaction is if the transaction is committed, if the transaction is committed, committed, then that will be stored into the main storage here. That will be stored into the main storage here. That is called the delta merge operation. Why? Because main storage is only optimized for the read plus compressed mechanism, not the write, which means you cannot write any data, any transaction directly into the main storage level. You cannot write anything here. Instead, you need to write the delta storage here. So why? Because delta storage is optimized for the read, write, compression mechanism. Means you can read the data, you can write the data, data will be compressed. Data will be compressed. So there is a there is a 10x compression technique. We'll use it here. 10x compression technique, which means if any data coming to the HANA database, suppose like if the 1 GB data is coming, means that will be compressed to the 500 MB to 600 MB, means in half percentage it will be compressed here. That is called the 10x compression technique. 10x compression technique. That is called the 10x compression technique. HANA, we have the inbuilt advanced feature is available. That is called the 10x compression technique here. So if any data which is coming to the here, then that is going to the, that will execute the transaction here. If the transaction is committed, the database language, it is the committed. But in our language, once you have done the transaction, means once you have done the ticket booking, suppose you are booking the movie ticket, then once you've done the movie ticket booking is completed, means the transaction is completed, then the committed transaction, the completed transaction will go to the main storage. So main storage automatically. When it will go, there is a if condition here. When the transaction is committed here, that is called the, so that is called the, so delta merge operation. This process is called the, every table we have the two main storages here, delta storage and main storage here. So when the transaction is committed, the first transactions, the queries, statements, everything will be executed in delta storage here. If that is executed, if that is committed, then the data will be moved to the main storage here. That operations are called the delta merge operations. That operations are called the delta merge operation. Sir, why can't we write directly into the main storage? Main storage is not optimized for the write, only read. However, the main storage operations are very costly. Why? Because all the committed data, not only the current committed transaction, the previous transactions, previous users transaction details, previous data, previous tickets booking details, so previous your bank account data, all will be stored into the here. So if the transaction is directly coming to the main storage, something is happens here, then it will impact the other transactions also here. So that is the reason SAP so introduced the delta storage concept here. SAP introduced the delta storage concept here. As part of this delta storage concept here, what's happening here as part of the delta storage concept? So all the data, whatever there in the system level, that is the delta storage, once the transaction is committed, that will go to the, so that will go to the main storage. That process is called the delta merge operation. Delta merge operation here. That process is called the delta merge operation here. Okay. So then what about the save point here? So what about the save point operation here? The save point operation will happen every 15 minutes. Every 15 minutes, the save point operations will happen, which means, so this all these things are will happen in the main memory. Then once the transaction here, once transaction is sitting here, once the transactions are sitting here, then same copy of data will come to the data folder. In the same copy of data will come to the data folder. So this mechanism is called the save point mechanism. This will happen every 15 minutes by default. Every 15 minutes by default, this will happen here in the system here. So here we can observe the save point interval, everything into the operating system level. If you go to the trace directory, so then you can go to the here trace directory. If you go to the tenant database, if you go to the index server, if you go to the index server, in the index server, you see the all the details and everything here, all the details and everything, you will get the all those things here, right? So why? Because, so you can see here, save point interval, save point, current save point version is this one. When it is happened, so every 5 minutes, sorry, it's a every not the 15 minutes, every 5 minutes, the save point will happen, not the 15 minutes here, every 5 minutes here. So that is the log backups. This is the save point. Save point will happen every 5 minutes once. The save point will happen here. See here 9 1, one save point will happen here 9 1, then 9 6, then 9 11, then 9 7, 9 17, then one more data 1 9 17. There is a one more save point operation, save point version, save point version, save point version. So which means, so every time, every 5 minutes, the data will be replicated from the your main storage to the your data folder at OS level. Why? Because here, why sir? Here, HANA is a in-memory database, right? Data is storing into the in-memory level. Okay, that is fine. But in case of something is happens in the HANA database level, all the data is gone. All the data is gone here. All the data is gone. So in this case, what will happen here? That is the reason. Also, everybody knows here this feature. So in case of the data is, why? Because RAM is the volatile memory. RAM is the volatile memory, which means only temporary memory only here. Only temporary memory only. In case of if any hardware crash, any file system crash, or something is happens, so what will happen? OS restarts or something is happens. Whatever the data is there here in the in memory, 1 TB or 2 TB data, all the data is gone. Gone means all gone here. Nothing will be there here. So in this case, all gone, nothing will be there here. Zero. Come to the zero. Then again, whenever you are starting the database, so it will load the data from the data folder. Sir, how we will get the data means, that's the reason. Once the data comes to the here, every 5 minutes once, the data is going to the data will go to the data folder level. So data folder level means folder level, it will store the permanently. But here it is also stored until you restart, until hardware failure, until OS restart, the data failures will happen here. So if you restart it, data gone. Then how about the data again? So again, you will get the data from here. So that's why every 5 minutes once, the data will be written into the data folder. That's why the data folder size is 3 into RAM size, 3 times of your RAM size. When we are discussing about the hardware requirement, your data folder size is 3 times of your hardware requirements here, right? So that is the reason we have the save point mechanism SAP introduced here. Save point mechanism SAP introduced here. See here again 11:16 just now. One more save point has happened here. One more save point has been happened in the system here, right? So this is the way save points will happen. We can track it in the index server trace file. The trace directory, we can track it all those things here. Okay. So that is the one here called this state point interval. Suppose if you want to prove it here, you can see free-g, right? What is the 32 GB here currently? It is full now, right? So now what I will do, I am stopping the database here. If I stop now, what will happen? Whatever the data is there in the memory. Why? Because now 32 GB used by memory. This is a memory usage. This is a RAM memory usage here. 32 GB usage. If I stop it now, what will happen here? Whatever the data is there here, all the data will be go to the data folder and all the data will be deleted from the RAM directory here. So if you want, you can see it now here. So now I am stopping here, which means all the data, why it is taking the some time, immediately it's not stopping means data, whatever the data is there, first of all, everything will be flushed out here on the ad hoc basis, or every 5 minutes the data will be moved to the here in the data folder at the operating system level. So one more thing is here, what about the log folders are here? Log folders are here. The log folder, every time whenever the data is committing to the here, every time data is coming to the here, the first it will go to the log directory, it will save it here, then only the data comes to the here, it will save it here. This will be frequently, whenever the transaction comments frequently, it will write the data into the doc folder here. Then it will write the data here. Why? Because save point will happen every 5 minutes here. Within this 5 minutes, something goes wrong, then you have the 5 minutes data loss, right? Data loss this 5 minutes. We are not sure what happened during that 5 minutes data. So that's the reason, to ensure the consistency, recoverability purpose. So every time frequently it will write the data into the your log folder. Your log folder, it will write the data into the here. That's why. So every frequently it will write the data to the here. But in the data folder, every 5 minutes it will write the data to the data folder here. So now you see you have stopped the HANA database. Now it's the 32 GB used here. Now if you do just free-g here, now it reduces to the 25 GB, 25 GB here. Means 7 GB got freed up. 7 GB or 7 GB got freed up from the system here. Why? Because and whatever the data in the HD1 data, all the data got deleted. All the data got deleted. Suppose you see we have the one more database, right? That is called the HDK ADM. Just stop this one also here. So each database will occupy the some amount of memory, right? If you stop it here, then now again, out of 25 GB, few more GB will be reduced here. Few more GB will be reduced here. Like this. So whenever you are stopping the database, all the data in the RAM memory will be cleaned up, will be flushed out in the systems, will be flushed out in the systems here. Okay. So let's see here. So now you see free-g, now it's used is the 7 GB here. So which means some other database also it's active. So it's occupying the main memory here. What is that? It is called the HDK. It's not the HDK, HDD here, HDD ADM. If you stop it HDD ADM also, that will now its usage coming to the zero. Usage will come to the zero here. Usage will come to the 0 here, HDB space stop button here. Now you see. So now it will come to the 0 status here. Right? That is the term. Then why again how the data will come into the picture means, how the data will come into the picture means here. So whenever you are starting the database here, what will happen? Whatever the data is there in the data folder, again it will be loaded to the main memory first. Again all the data will be loaded to the main memory first here. When you are starting the HANA database, when you are starting data will be loaded to the data. Why? Because data folder nothing will happen. Only RAM data will be, RAM memory will be deleted when you are stopping. So nothing will happen here. So right now you see free-g. Now see it's a 0, means it's a 1. Very free percentage is there here, which means all the data you gone it here. Now let's go to start the database here. That is called the HD1 ADM. Right? You are going to start the database using the HDB space start here. So capital HDB space small start button here. Right? Just whenever click this button, what will happen here? Data will be loaded to main memory. From data folder to and RAM memory, it will be loaded. Sir, how again data will come into the picture means, so because of one copy of, before stopping, a copy of data is stopping is saving into the data folder. So whenever starting, it automatically it will load the data to the RAM memory here. We can see it here, right? So just you click the HDB start button, then immediately go to the so one more session, you can take it out. Then immediately we can take the HD1 ADM, then CD trace, then here you can CD trace here, then you can go to the index server. Why? Because all the data will resides only index server only. Now if you see the index server trace, all the data will be loaded here. In the index server trace, all the data, it won't start immediately. HANA will take the very longer time to start it here. HANA will take very longer time to start it here. So if you see the loads means all the data will be loaded, all the tables will be loaded. So see here, keep on, now it's in this page, post heap allocations base here. So now see data, how the data, these all are the tables here. These all are the system tables here. All these tables will be loaded here. All these tables will be loaded here. Now you are in the, so 13, what is the table? So this is the this is the one table. So post heap allocator base table, this is the one here. Right? See here, all the tables, how it is, how fast it is loading here. Now you are in the task executions here. So you can see the BMC. See here how the tables are loading here. Now you are here, right? See here how the tables are getting loaded here. Here how the tables are getting loaded into the system. So which means still it is not started. Still you can see it is not started. It's starting mode only. When it will complete it, once all the tables data loaded, then it will give like database is successfully started, something like that. We will get the prompt, successful prompt. We will get it out here. You can see. So these all are the tables here. These all are the tables here, statements and everything here. So what exactly happening now here when you are starting the HANA database? So all the data, whatever there in the data folder, it is going back to again here into the your main memory. In the main memory, it is going to the main memory here. So now it started. Now it is started. You got the prompt here. That's why it's not going to the next screen here, next step here. Now you can see the main memory. Now you can see the memory usage. So right, you can just use the free -G here. You see 7 GB used here. Previously, it's a 1 GB. After starting the HANA, 7 GB used here. So it's keep on you are using, then data loaded to the main memory here, which means HANA is storing the data. With this practical, we can see HANA storing the data in memory. Whenever you restart the database, or any hardware failure or OS failure, all the data bits, all the data loaded to the main memory. So disk from main memory, right? So in the disk to, sorry, main memory to disk here. Whenever you are restarting, what will happen? Again, it will be reloaded to the data folder to main memory here. So what exactly happens? What exactly happens when the time of data HANA starting here? The first one here. Okay, this sequence of steps are very, very important here. Nowhere written, or so it's a very internal process. These all are the internal process here, right? So what will happen here whenever you are starting? So here, so first system row store tables here, or system. This is called the system tables. System tables will be loaded first. There is a sequence of activities here when you are starting the HANA database. This will happen in the back end here. Whenever you click on the HANA start first, what are the system configuration tables and everything are there? Those tables will be loaded to the main memory. Then, so secondary indexes will be created. Then the third one, then column store. Now business column store tables, means business store tables will be loaded. Then the fourth one, roll forward. Then fifth one, roll back. Roll back will happen. Roll forward, roll back, and HANA will be started here. These are the 5 sequence of activities will be performed in whenever you are starting the HANA database in the HANA database here. So which means, so whenever you click on the HANA start, row store tables, secondary indexes will be created for the row store tables. Then column store tables are called the business store tables here. Then roll forward. Roll forward means here, roll forward tables means here. So whenever when you unexpectedly you stop the system, but the transaction is committed, but not saved into the data level here. Then in this case, the transaction will go forward, then it will save into the here again file system level. So again, you unexpectedly stopped the system, but the transaction is not committed, still in the delta merge operation only, still in the delta merge. So this is in the here itself in the, it's not completed. So you are trying to book the ticket, you are searching, payment is done, but while getting the ticket confirmation, then your session got cancelled or some, there is an internet issue, there is a server issue. What happened? Your ticket transaction is not confirmed. Then after some time, your statement will be rolled back. Then your amount will be refunded to the your account within 24 hours or whatever it may be. It will be refunded, right? That is called the rollback statements. Roll forward means, hey, you booked the ticket. You booked the ticket. Transaction is completed. You booked the ticket. But while you are getting the confirmation, sometimes what happens? So your power is gone, our internet is gone. Some glitches happen, network or some server issues. So, but you back end ticket is booked while giving the confirmation to you, but the transaction while giving the confirmation to you, it means there is some issue. It got shown the confirmation, right? Then after some time, your statement will go roll forward, and you will get the ticket to the your mobile or message or mail. You will get to the mobile here saying that your transaction is completed successfully, something like that here. So just for example, outside of the example to understand better purpose, I told you the ticket details here. So like this, the transactions will go forward and will commit the will go forward and execute it here. Then rollback means it will be rollback, and so it will go with this one here. So normally we see in this type of issues, maybe whenever we go to the ATM shops or any banking ATM or somewhere. So if you go ATM shop, even if you withdraw the money, the amount will not be come from the ATM machine, but the amount will be deducted. When you see the account, your message has been, you got the message saying that some 2,000 got deducted from the your amount. But after your inquiry, or you don't need to worry. Just you wait for one day, automatically the amount will be refunded. But because the rollback will happen, the rollback statements will be happens in the systems. So that will happen. So you no need to worry about the everything. Normally, come hurry situation, we may call to the bank person or bank customer care. Everyone, they told that don't worry about your transaction. So we will revert it. You will get the 24 hours. Your amount will be refunded, something like that. You will get the some confirmation from them, right? Same thing they will tell you. Why? Because it will take some time to roll back your transaction and everything here. The same thing here. Okay. So that is called the, so roll forward, roll back, and this is called the delta merge and save point interval. Right? So within the 5 minutes, so something is okay, fine. Suppose up to so 9:30 the transaction is committed. Then next transaction 9:35 it should go to here. But in between 9:30 to 9:35, 9:30 now, 9:30 to 9:35, so the system got crashed, which means 9:30 data is available, but same 9:30 data should be available here, but transaction is gone. So now when you are starting the data, it will recover, it will store the data up to 9:30 only, right? 9:35 data, so everything is gone now. So what about that data here? So what will happen? So in the log folder, we have the continuous data is available in the log folder. So the logs will be replayed. So in case of any roll forward, then immediately it will go and roll forward it. In case of rollback, then the transaction will be rollback will happen here. The data will be rollback will happen here. That is what will happen. That's why we have the roll forward and the rollback statements will happen whenever you are starting the HANA database. This will happen. This will happen in the systems. Okay, got it? Clear? Any questions? Anyone?
Sir, can you explain again? I couldn't get it. The log part.
Log part. So, okay. So in the HANA log folder, it will continuously, it will write into the HANA log folder here. There is no time limit. Why? Because first it will write the data to here, then only it will store the data into the, in this place. It will store the data into the here only, means in the main storage only. Why? Because the RAM is the volatile memory. We cannot trust the RAM. If something is happens, you have the data loss. That's why safer side, whatever the changes are happened, the log changes, the changes about the data it will create as a one log statement in the log transaction, in the log segment. Then it will store the data, it will store it here. Then only it will commit the data into the here. Then only it will commit the data into the main memory itself here. Means and then only it will store the data into the committed entries will be stored here only. Why? Because in between something is happens, we have the data in the log folder, the saved changes and everything is available here. So if something is happens, we can just replay the logs so that we have the data will be saved into the here as well here. That is called the log folder here. So sometimes what happens, your data, whenever you restart it, only selective tables, only selective data, only those data will be loaded to the main memory itself, not all the data here. So that's the slowness. That's why whenever you start the databases, initially it will be very slow. Initially it will be very slow here. After some time, what will happen? Whenever you are accessing the transactions, if the data is not available, suppose you are checking the data, you are searching the data is not available here, what will happen? It will go to the data folder level, it will search the data, then it will reload the data from here to here, here to here, it will load the data here. That will happen. Also, we can manually also perform the load to the manually. Suppose if you want, there is a table A, B, C, D. You want this table should be here, or you want the table should be here. You can also confirm that one here. So why? Because all the tables should be here means there is a license. Why? Because HANA license is based upon the main memory. HANA license are based upon the main memory. HANA license is based upon the main memory here. So how much you are using, you have to pay the amount for that much of license here. So if all the tables data storing here means, so if some unuseful data also not required means, you can reload to the data folder. Why? Because data folder there is no license, only main memory we have the license. So here you can see in the catalog, we go to the catalog here. Here we have the list of schemas here. Schemas. We go to the any one of the schema. Schema means the table owner. Table owner here. Okay. Let's skip this part. I will tell you later. Why? Because now you will get confused here. Okay. You will get confused. So leave it that part. So that is the log folder. Log folder continuously it will write the confirmations and communication to the log folder here. As and when required, it will just replay the logs into the system. Then so it will be roll forward and roll back will happen into the system here. That is called the rollback statements here. So roll forward and the rollback will happen from the log folder here. Okay. So one more thing is here. So sometimes what happens? Sometimes the log folder will become full. Why? Because here the log backups will happen every 15 minutes. Every 15 minutes, the log backups will happen. Why? Because data continuously writing into the log directory here. So every 15 minutes, log backup should happen here. So here, whenever log backup happens, this logs will be cleaned up here. The backups, the logs will be cleaned up here. So this folder will be become free. So here, if the log backups are not happening, whenever your transaction, your HANA log is 100% full, HANA log 100% full, what will happen? HANA log 100% full. Then system will not commit any transaction. Then system will be in the hung status. Why? Because if you want to commit the transaction, then the first you have the enough memory is there. You have the main memory full is there, 1 terabyte space is there, but your log directory is full. Then sir, I have the main memory, HANA is writing the data into the main memory, then why sir we have this type of issues here? Why HANA is not committing any transaction? HANA is still stuck. Why is not committing? Why? Because your log directory is 100% full. So in this case, what will happen? HANA log directory 100% means which will not take any committed data from the your main folder. Then here it is not taking means here it will not commit, it will not all the transactions will be filed up, means it will be stuck here. So then it will not be any transaction will not execute it here. Why? Because here the delta merge, this delta merge are not happening. Delta merge save point mechanisms are not happening because of the log directory full issues. So because of this reason, your HANA will go to the hung status. Hung status. then what will happen whenever you extend it? If the hung status, then we cannot do anything. 100% full, even a log directory 100% full, we cannot do anything here. Either we have to extend the space, or we have to map this log directory to the map. OS level, there is a soft link to the some available free space, which directory, temporary solutions only. These all are the temporary solutions only. So why? Because HANA is not committing. Now it's a production business operations. If you restart it, all the data is gone, or some data loss, some data loss will happen. In this case, what will happen? So in the log directory data, so we need to map to the some other directory location. We have to create the soft link. Maybe Linux team, or we can also create it. If you have the root access, then ls minus ls, then target path and source path, we can use this syntax. We can create the soft link. Soft link, we can create it. So that what will happen, instead of storing the data to the here, then the log directory, it will store the data into the some other directories. Some other directory, it will store it where we have the free space. So in this way, we can save it. We can save the logs. If the logs are happening successfully, definitely HANA will commit the transactions. The log backups also will not happen here. Why? Because backups also will not happen. Why? Because if the directory is full, how the backup will run? Backup also will not run. So we have the problem. So that's why, as part of the day-to-day monitoring, we need the backup status also. We have to check the backup status and all those things also. We need to check it out. Okay. So that is the
we
delta.
cannot do any housekeeping, like any older logs move to another location, and by removing the logs, older logs.
We cannot move from the log directory logs. Either backup, system internal backup should move it, or we need to check the why backup is running. We have to do it. And there is a one weekly task or one task. There is a reclaim alter. There is a reclaim option here, a log reclaim here. So the free log segments, alter database, there is a alter database, reclaim log folder. There is a command. I will explain more details in the coming classes. So we have to execute this reclaim log statement commands, so that what will happen? So if any free space is there, that will be, the space will be reclaimed. The space will be reclaimed. Then we can immediately run the backup. If the backup is running, definitely you will get the free space. So why this folder means? Because of the backup. Sometimes backups, it won't run. Maybe we miss it. Sometimes we may miss it out during the night time, or sometimes we may miss it out. So that's the reason the log directory will become 100% full. The log directory full, system will not send any transaction to the file system level. The file system is not taking any transactions, means HANA will not commit any transaction. So that's the reason what will happen. So HANA will go hung status here. So SAP also will not commit any transaction. So the transaction will not be saved. System will go hung status, and system will become so unstable. So in this case, okay, DB file system is causing the issues. Then in this case, what we can do? Maybe as a temporary solution, we can create the soft link, and so we can create the soft link to the another drive. Why? Because this log directory is 100% full. So we have the another directory, maybe data folder, some other directory where we have the 100 GB, 200 GB space is there. Then just to route the logs to this transaction logs to the some other directory here. Then all the transactions will be saved into that directory. The transactions are saving means definitely it will send the commit. So it will commit all the transactions. Then whatever the filed out transactions and everything, the backlog, all will be cleared. All will be cleared here. All will be cleared here. That will happen in the system here. Okay. So that is what will happen. Then, so how to create there is a procedure. So in case this log directory is full, soft link we have to create it. Then after that, so then there are a lot of activities like bring up the system. Then so wait for some time. So all the transactions, then run the backup. It will be cleared. The lot of steps we have to perform it. So then, and also we can also execute the reclaim command, some housekeeping activities. So this type of activities we have to perform it, actually reclaiming. So this one. Otherwise, we have to schedule the weekly ones, or weekly once, or maybe monthly once, or daily 3 times weekly, maybe whatever it may be frequency. If you set it out, the data will be reclaimed. The data will be reclaimed here. So that options we can choose it here. That is the thing we can do it here. So normally, suppose in our case, I know this type of situations will occur. So what we have written the scripts at in my organization. I have written the scripts.